In example 6, we took exponents and we transformed them into logs so that we could solve for variables that were in the exponents. In example 7 and 8 here, we're going to go the other way. We're going to take things that start as logs and we're going to turn them instead into exponents in order to solve them. Example 7, page 350. We have 4 log base 3 of x equals negative 8. All right, so to solve this one, we want to go and turn it into an exponent. So again, back to the definition of log. Log base b of x is equal to b to the y equal to x. So first, before we can get it to do that, though, we need to have the log by itself. That's kind of the first rule of thumb. So we want to divide both sides by this 4. So that log base 3 of x is equal to negative 2. Right? Negative 8 divided by 4 is negative 2. And now that it's in the log form, as in log by itself on the left and some number on the right, we can take advantage of that definition. So the 3 is our base, the y is our negative 2, and of course x is still x. So this is saying that x is equal to 3 to the negative 2. And we know what 3 to the negative 2 is. And remember, 3 and 2, that's 9. Negative means put it into the denominator. And so it looks like our answer here is going to be 1/9. And there you have it, example 7. We're not going to worry about part B. Part A is the most important piece. All right, let's clear this off and let's do example 8 next. All right, we're back to a clean workspace here for example 8. And example 8 says that we have 6 plus 3 natural log of x equal to 12. All right, so much like the last problem, we want to isolate the log, or in this case, the natural log by itself on the left-hand side. So the first thing we need to do is transfer this 6 over, or subtract 6 from both sides, whichever way you like it. That's going to make 3 natural log of x on the left, and 12 minus 6 on the right. Of course, 12 minus 6 is 6, and so we're at 3 natural log of x equals 6. Now we need to divide both sides by 3. Again, the purpose of that is to isolate the natural log on the left by itself. So natural log of x is going to be equal to 2 in this case, because 6 divided by 3 is 2. All right, now it's time for definition, because the natural log, remember, has a base of e according to our rules. And so that means that we're going to have a base of e to the power of 2, that's our y, equal to x. And so this problem has become e squared. E is a number, much like pi, goes on forever and ever and ever. So our calculator has that already in it. So let's bring our calculator back into play here. Again, clear anything off that may be lingering from a previous problem. And we need to say e squared. Now, when you look on the calculator, there is an e on here. Actually, there's 2 of them. There's one that is the second function above the divided by sign here. And there is another that is attached to the ln button. I like the one on the ln button. So I'm going to hit second, then I'm going to hit the ln button. It's going to say, e to what power do you want? I'm going to say 2 and say enter. And it's going to say 7.389 is my answer. So 7.389 is the answer for x. So pretty cool that way, taking something that started as a log and turning it into an exponent so that we can solve it. Again, the key to this problem is making sure you isolate the natural log or the log by itself before you invoke the definition of log.